Hi and welcome to the third part of this tutorial on C# classes. Before we get into it, please like, subscribe, share, comment. It will be greatly appreciated. And please hit the bell icon to be notified of future content. If you haven't seen the first and second parts of this tutorial on C# classes, please see links to these videos below in the description, and please view these videos before continuing with this tutorial. So let's add another class to our employee component project. Let's name this class employees and give it a public access modifier, which means this class will be accessible by any code within this solution. This class will be responsible for managing a collection of employee objects. Each employee object denotes an employee record. Let's define a private member variable, which is of the type ArrayList, and let's name this variable _employee list. The ArrayList type in C# provides us with the mechanism to add objects to a list. So what is an ArrayList? An ArrayList is a non-generic type of collection in C#. Non-generic, in this context, simply means that this collection type does not get strongly typed at compile time, and that any C# type can be added to an ArrayList. The advantage of using an ArrayList over an array is that the ArrayList grows dynamically. This means that the developer does not need to establish the number of elements that will be stored in the collection when defining a variable as an ArrayList. A disadvantage of an ArrayList can be that it can store heterogeneous elements. When assigning a variable with an items variable stored in the ArrayList, the item must first be cast into its appropriate type. We'll change the ArrayList to a generic list in an upcoming tutorial to highlight why it is in fact better to use a generic list type to store like elements. But for now, we'll use an ArrayList to store a collection of employee objects. Let's create a parameterless constructor and instantiate the ArrayList object that will store a collection of employee objects. An example of encapsulation is presented in the employees class. The underlying ArrayList collection object is a private member variable, which means it is not directly accessible to code outside the employees class. The employees class essentially encapsulates the ArrayList functionality. So let's create a method that does not return a value. The void keyword is used in the method definition to denote that the method does not return a value. And let's name this method seedData. It is a private method and will be responsible for initializing the application with employee records. So in a real-world application, the ArrayList would likely be initialized with data from a database. Here, for testing purposes, we are initializing the _employee list collection with data. So in order to add an employee item to the _employee list collection, we want to encapsulate the ArrayList's add method. So let's create a method named add in the employees class. This method will be public and will not return a value. The code in this method will simply add an employee object to the _employee list collection. So let's now implement the code for the seedData method. We can now use the add method that we have just created to add items to the _employee list ArrayList. Notice I am using the this keyword, and Visual Studio provides us with IntelliSense, and you can see that the add method is included in the IntelliSense dropdown when we type the A character. So the this keyword in this context refers to the current object that has been instantiated from the employees class. Note that the this keyword can be used to reference the object created from the class in which it resides. So in order to add an employee record to an employee's object, we first need to construct an employee object. So I'm going to create a new class that will handle the construction of certain objects for the employee CRUD application solution application. Notice how each of our classes in this application has a single responsibility. The employee class stores data for a single employee record in memory. The employees class stores and manages data for a collection of employees. The class we are about to create will be responsible for constructing certain objects for the employee CRUD application solution application. This class can be referred to as a factory class. Its purpose is to abstract the construction of objects. So let's name this class Employee Object Factory. Let's make this class public and static, and we'll create a public static method within this class that returns an employee object which will be constructed in this method. Note that this factory method contains 5 parameters, each of which corresponds to one of the 5 updatable properties of the employee class, namely first name, last name, annual salary, gender, and is manager. So let's go back to our employees class and add 4 employee objects to the employees collection within the seed data private method. By abstracting the construction of the employee object, we can in effect change the implementation of the construction process without affecting the calling client code that we have just implemented, i.e., the code implemented for adding employee objects to the employees collection. So let's demonstrate this and change the way we construct employee objects within the appropriate method in the Employee Object Factory class. We can construct an employee object by implementing the new keyword and setting the public properties with values, thus ignoring the employee class's parameterized constructor like this. And now if we go back to the employee class, we can neaten our code by changing our public properties to what is known as auto-implemented properties. The syntax for these auto-implemented properties means we can remove any code implementation for the relevant properties. We can also remove the private member variables that are initialized with values within the parameterized constructor, and we can remove the parameterized constructor altogether. This in effect means less code to achieve the necessary functionality for our employee class, which makes the code less cluttered and easier to read. So let's go back to our employees class and create an update method which will be responsible for updating the fields of a particular employee object within the employees collection. Let's create the delete method. This method is responsible for deleting an employee object from the employees collection. Let's create a find method that will be responsible for finding an employee within the employees collection based on the ID property value of an employee object. The find method will return the index, note the collection is zero-based, of where the relevant employee object can be found within the collection. If the employee is not found within the collection, -1 is returned. Note, this method may not be the most efficient way of finding an item within a collection. For example, we briefly discussed arranging sorted arrays as binary search trees to increase search efficiency in the C# methods tutorial, but this linear search implementation will suffice for our purposes for this application because we are dealing with a fairly small amount of data. And now let's include a public method named count, which returns the number of employee objects stored in the employees collection. And the count method works alongside the next piece of functionality we are going to implement within this class. We are going to define an indexer for this class. This indexer functionality enables calling client code to treat an object derived from the employees class as if it were an array. You can see we are using the this keyword followed by open and closed square brackets. Within the square brackets, we are using an integer parameter as the index for each of the employee objects stored in our employees collection. And to implement the indexer functionality, the get and set keywords are used in the same way that a property can be implemented in C#. The set section of this indexer code is used for updating a collection item at a particular position in the collection. We are not going to need this in our application, so we'll only implement the get section for our indexer code. The get section is used for returning an employee object from the employees collection based on the unique index of the employee object within the employees collection. So note that we are explicitly converting the item retrieved from the _employees list array list to an employee type. We must do this because an array list could potentially store any C# type that inherits from the system.object type. Remember, all C# types ultimately inherit from the system.object type. And lastly, we can enable our employees class to be traversed within a for each loop by exposing the enumerator of the underlying array list, the _employee list array list. The details of the getEnumerator method are beyond the scope of this tutorial, but basically this code allows the client code to traverse the items stored in the employees collection through the use of a for each loop. So we have now implemented the employees class that serves to encapsulate the management of employee objects within a collection. Let's create a new folder named Views where we will place classes concerned with user interface presentation. So the first class that we will create in the Views folder will be responsible for presenting a list of all the employee objects and corresponding data within the employees collection to the console screen in a tabular format. So let's name this class Employee Records View. Let's make it a public class. Let's create a private member variable to store the employees collection. Let's create a constructor for the employees records view class that accepts an argument of the employees type. The code in the constructor will simply assign the _employees private member variable with the employees collection passed in as an argument during the construction of an employee records view object. And let's include one method in this class that will be public and will not return a value. Let's name this method runRecordsView. This method will be responsible for presenting the employees collection to the console screen in a tabular format. So to achieve this, we can simply loop through the collection of employees using a for each loop and write the string returned by each of the relevant employee objects, getEmployeeInformation methods, to the console screen. But we also want to create a heading for each of the columns corresponding to each of the employee object's properties. So let's create another class where we can store common text output for this application. Let's name this class Employee Common Output Text. Let's make it a public static class. Let's then include within this class a public static method that returns a string that stores a suitable header for our tabular representation of the data for the employee records. So let's name this method getColumnHeadings. Let's create 6 string variables, each corresponding to an employee object's property. We are using string interpolation to include the values of the variables we have just created. We are using the padWrite method to ensure uniformity of our column headings and corresponding column values. We are using the \t escape sequence to ensure neat column spacing. And we are using the \n escape sequence at the end of the string to force a line feed. Please note that if you have any issues with the \n escape sequence, which should force a line feed, you are able to replace this escape sequence with the environment.newLine code within curly brackets. For the purposes of neat formatting, I'm going to use the string object to create an appropriate dashed line under each of the column headings. So let's return to the Employee Record View class and write the column headings that we have just created in our Employee Common Output Text static class to the console screen. And this code is appropriately placed above where we are traversing our collection of employees and writing the appropriate employee data to the console screen. So now we are going to return to the main method in the Employee CRUD application example project and implement code to output a tabular representation of the employees collection to the console screen. Let's first instantiate an employee object using the new keyword. Let's open the Employee Object Factory class so that we can abstract the construction of the Employee Records View class into an object. Let's name this method Employee Records View Object. This method accepts one argument, which is an object containing a collection of employee objects. And the code for this method simply constructs an Employee Records View object from the Employee Records View class and returns the object to the calling code. Note that the employees object is passed as an argument to the Employee Records View class during the construction of an object derived from the Employee Records View class. Right, let's return to the main method and call our newly created public static factory method to construct and return an Employee Records View object. So we want to include a main heading for our Employee CRUD application example application. So let's open our Employee Common Output Text static class and create a static method named getApplicationHeading. Let's give this heading the text Employee CRUD application. I'm also going to create a private method that will create an appropriate underline for a heading. It accepts the heading string as an argument and generates a contiguous string of underscore characters where the number of underscore characters corresponds to the length of the header string passed into the method. We can then reuse this underline method to create an appropriate underline for any header we wish to include in this application. Let's go back to our main method and implement the code to output the application heading to the console screen. Let's then call the runRecordsView method on the Employee Records View object. And let's run the code. And you can see the data corresponding to a collection of employees is outputted to the console screen in a tabular format, as expected. We'll continue with the development of our Employee CRUD application example in the next part of the C# classes tutorial. Please remember to like, subscribe, share, comment to support the channel. It will be greatly appreciated. And please hit the bell icon to be notified of future content. As always, the code created in this tutorial can be downloaded from GitHub. Please see a link to the relevant GitHub repository below in the description. Thank you and take care.